The driving question behind this week's experiment was, what does emission intensity depend on and what does it not depend on? The hypothesis being tested was that emission intensity is completely dependent of energy input and that it is completely independent of the emitting substance. So, what exactly is emission intensity in terms of emission spectroscopy? Emission intensity is proportional to the number of photons emitted from a substance. The more photons emitted at that wavelength, the higher the peak on the emission spectrum. It's like trying to shoot wadded up pieces of paper into a wastebasket. The more you shoot with the proper amount of energy to get into the basket, the higher the mountain of paper becomes. There still will be some pieces of paper surrounding the mountain. These are the photons that were emitted at similar wavelengths, but not the maximum wavelength of emission, so their intensity is not as high. Depending on the energy put in, the base of the peak can be wider or narrower, just like how if you throw with less energy, the paper will land farther from the basket.
The energy for excitation of electrons was provided through a chemical reaction between the fluorescent dye and the activator. In this reaction, a milliliter each of red and green dye was supplied with a milliliter each of activator, meaning energy input was constant for both of the reactions. Our results show that the green dye is emitting higher energy wavelengths, meaning it must be absorbing lower energy wavelengths compared to the red dye, which is emitting lower energy wavelengths and thus must be absorbing higher energy wavelengths. This means that the green dye absorbed more photons than the red dye and thus released more photons when electrons returned back to the ground state compared to the red dye. Thus, emission intensity depends on the color of the dye. Additionally, emission intensity also depends on energy input. Since glow sticks involve a chemical reaction, photons can be emitted as long as there's activator to supply energy. Thus, the amount of activator can affect the intensity because more activator means higher intensity.
When the red and green dyes are separate, the green peak has a larger intensity than the red peak. As we can see, when the two dyes are mixed, the red dye has a larger intensity than the green dye. This is due to the fact that once they are mixed, the red dye absorbs the energy that the green dye emits. Because of this, the red peak will have a larger intensity than the green peak, which is what we see. An example of this in real life is something that we see every day. Every child is somewhat a mix of their two parents. Even though we are a mix of our two parents, our genes still contain the traits from our mother and father. Similarly, the orange dye, the child, was a mixture of the red and green dyes, the parents, but the orange dye spectrum still had peaks of high intensity at the same wavelengths where red and green had their lambda maxes.